Good afternoon, colleagues. This is Mr. M. Shoba from Bharat Malokwane, the acting SES for Electrical Technology. It is a pleasure to have this session for Power Systems Exam Preparatory or Guideline for the year 2020. So let's start. Power Systems Exam Preparatory Guideline for year 2020. In this paper, we have 6 questions. Question 1, that is occupational health and safety. The second one, that is question 2, RLC circuits. Question 3, 3-phase AC generation. Question 4, 3-phase transformer. Question 5, 3-phase motors and starters. And then the last question, there is question 6, it's a PLC, programmable logic controller. So marks are allocated as follows. So the first question is 10 marks, second question is 40, third question is 30, the fourth question is 30, and the fifth question is 30, and the last question is 60 marks. So the paper is out of 200 marks. So my advice to the colleagues and to the learners, it's easy to pass the subject if you look at the allocation of marks. For example, if the learner can focus mostly in question 2 and question 6, that is 100 marks. So the learner can get 50% plus or minus. And then, in actual fact, there are choices here. For example, question 2, question 3, question 4, it's also giving us 100 marks, that is 50%. So every educator knows his or her learners, their strong points. So if you really want your learners to pass, then you will decide which question will put more emphasis on in order for them to get good marks. All right, remember we are striving for quality, again 100% and the best average. All right, let's start. Question 1, occupational health and safety, that is 10 marks. So this topic, according to the last year report, it was poorly answered by the learners. We even noticed on the exam preparatory for trial that most of learners did not get 10 out of 10 there, or even 50% of the question. So these are the things that we need to emphasize to the learners. The first one, educators should make learners aware that other questions are not presented as in their textbook. Those questions need learners' insight, skill, and knowledge when they answer. These we say, or we refer to high order questions. All right, the second bullet says such questions have more marks, and that is where marks are lost because they will be writing a point instead of elaborating to get full marks. For example, in most cases, when they talk about the acts, so learners, they need to elaborate. Like if the question is asked, for example, explain the risk analysis. So the learner needs to elaborate what is all about the risk analysis. Different approaches may be used to make OHS chapter more interesting. Practical work is the best way to explain, exercise safety, and assess learners. While you are working in the workshop, you keep on reminding them, this is unsafe act, this is an unsafe condition, this is a hazard, etc. So that is how they learn safety. The second bullet, it says a visit to a certain company such as ESCOM where safety is observed at all times, and the instructor will emphasize the topics within the scope of the syllabus. But it's late now to do that. We shall do it with our grade 11s. We'll be doing grade 12 next year. The next one, use of video during tuition addressing OHS and its importance in the workplace. Nowadays we use internet, so use more internet to put more emphasis on this question. The next one, learners are also urged to apply skills and knowledge from grade 10 to 12 in order for them to answer this question. For example, if the question comes and says, how do you help someone who is bleeding? Remember, that was done in grade 10. So in this question, they asked actually questions from or things that were done in grade 10 to 12, not only in the grade 12. Learners should state the act the way it is stipulated in the OHS Act. They should not use their own words, especially when we talk about the act on the textbook, referring to this question of OHS. All right, the second question, that is RLC, question 2, RLC circuits. I feel like this is the easiest question where learners can grasp a lot of marks in it. Let's go through it. So for last year exam, this topic was fairly answered. Educators should emphasize that a definition of terms sometimes can be determined from the formula of the particular quantity. If the learner have forgotten the definition of the definition, so the learner can use, sometimes the learner can use, let me go down, the learner can use the formula sheet to determine or to define whatever is asked from the learner, like inductive reactance, the X, the XL. Educators should remind learners the following. Write the correct unit for quantity to be calculated. For example, R is measured in ohms, XL is also measured in ohms, XC is measured in ohms, the L, the inductor, is measured in Henry. So some of the learners, they confuse the units, so we need to emphasize them now and then, now and then, now and then. Use the correct formula for quantity to be calculated. Learners should not mix the formulas. For example, if they are asked to calculate XL, the inductive reactance, that will be 2 pi FL. And if you look at the formula sheet down there, all the formulas are placed in order or in orderly manner. You see there is RLC only here. And there is series RLC, there is parallel RLC. So everything is on the question paper. Manipulate the formula correctly, making a quantity the subject of the formula. This is also a problem to other learners. In case they say calculate C from the capacitive reactance. Now the learner is supposed to manipulate the formula, make C a subject of the formula. It's a problem to other learners. So let's keep on teaching them, showing them how to manipulate the formula before they substitute. Application of correct prefixes in the substitution, like 16 microfarads, that is 16 times 10 to the power minus 6 farads. This is also a problem to other learners. They just mix prefixes. If it's micro, the other learner will use nano to the power minus 9, of which is wrong. So it is emphasized that we as educators, maybe we write the prefixes saying micro times 10 to the power minus 6 versus the mega times 10 to the power 6, so that they see the difference between the two. You also write the kilo, that is times 10 to the power minus 3. No, that is the milli times 10 to the power minus 3, and you also write the kilo times 10 to the power 3, so that they see the difference between the two, the milli and the kilo, the micro versus the mega. Effect of frequency on a reactance or reactive components. This is also important. In some questions, they will say or ask, what will happen if the frequency increases? Now the learner need to know or need to maybe apply the formula. If there were some calculations in the question, apply the formula, increase the frequency, not using the given frequency. If the question says, what will happen if the frequency increases? Now, if the frequency was 50, the learner can use 100 hertz, and then calculate maybe a new Z if the question was saying, what will happen to the impedance if the frequency increases? And the learner calculate the new Z and compare the two now, the initial Z and the present Z, so that the learner is able to answer the question, whether the impedance will increase or will decrease. Make use of a formula sheet. Sometimes they write a wrong formula. The learners, they must always use the formula sheet. It's written in orderly manner. As I've said before, effect of, all right, this one. Draw sketches, sometimes they cannot differentiate between waveform and phasor or vector diagram. So this must also be emphasized because it has a lot of marks. Learners are unable to use calculator to find correct answer, especially with formula consisting of Pythagoras theorem, like the impedance. So these learners, they need to use calculator now and then, now and then, now and then. I always say the learner must always at least do the calculation 3 times to confirm the answer from the calculator. When they draw phasor diagram, they should include the direction of rotation. This is very important because the direction of rotation will give them a mark. All these points indicated above, marks are being lost. Educators are to encourage learners to test answer 3 times when they do calculation before they proceed to the next question or calculation. So this is very important. And then the last one on question 2, simulation 1 on RLC will also help learners to understand this chapter well, and the teacher must highlight points like the effect of frequency on the reactive components, as I've explained before. Right, let's move to question 3. Three-phase AC generation, that is 30 marks. This topic was poorly answered in the previous year, but we hope this year learners will do better. Educators should highlight the following mistakes done by learners. The first one, learners should also be reminded the difference between the advantages and disadvantages of three-phase over single-phase. This is very important. The second one, they draw the sketch without labeling it. The sketch should indicate the phase shift of 120 degrees, like this diagram, the waveform diagram, this one, and also indicate the phase sequence RYB, phasor, and waveform diagram. Please note the one on the textbook have a little bit of mistakes. So educators should tell the learners to stick on this one, or they use the one on the previous question papers. So when they draw this waveform diagram, what is important here is the phase sequence, RYB, red, yellow, blue, the plus V and the minus V and the 0 volt there. Lastly, the shift of 120 from 0 up to 120, there is the first 120, there is the second 120. So these are the important points to get full marks in this question. On the calculations, learners should write the correct formula and correct units. No units, no mark. So learners must always write the answer that they got and the units. The answer without a unit, the learner will not be awarded a mark. Correct prefixes should be emphasized when calculating total power on the wattmeter. Like PT equals to P1 plus P2, 8 kilowatts plus 3 kilowatts, or 8 times 10 to the power 3 plus 3 times 10 to the power 3. Then the learner will get full marks. No prefixes, no mark. Definitions can also be taken from the formulas in case the learner has forgotten the definition, e.g. efficiency is the P out over P in. The learner can say efficiency is the ratio, remember the division, it's a ratio of output to the input power. Then the learner would get full marks of the definition. So every time if the learner have forgotten the definition, the learner can just go back at the formula sheet, the last page of the question paper, and check the formula. Oh, there is efficiency, and the learner can define efficiency from the formula. Correction of power factor or power factor correction should be emphasized at all times. This is a low order question. Learners should get a total on it. All right, the next one. Formulas are always given at the formula sheet, and they are always in orderly manner. This should also be emphasized. In other words, you can tell your learners as soon as they're allowed to start writing the exam, you tell them that maybe they go at the back of their question paper on the formula sheet. On RLC circuit, they write question 2 so that they know that all the formulas for question 2 are here, or are under, like, let me just go to the formula sheet. Like the learner can write question 2 there. So the learner will know that all the formulas related to question 2 will be found here. Here the learner can come and write question 3. Then the learner will know that all the formulas related to AC generation, they will be found here. Question 4, all the formulas related to three-phase transformer will be found here, etc., etc. All right, let's move to question 4, three-phase transformer. This topic is or was poorly answered last year. Educators should emphasize the following aspects: transformer configuration or connection, type, e.g. the star star, delta delta star delta delta star. Types of transformers, that's the shell and the core. So some learners, they confuse the two, the transformer type and configuration or connection. So this must be emphasized also. Principles of magnetism should be strongly emphasized. It can be taken from the textbook or previous exams. Grade 11's work on magnetism is also important, e.g. a definition of magnetism, mutual inductance, self-inductance, Lenz's law, and the Faraday's law, and many more. Operation of the transformer, important points should appear on the explanation. So this is, I think about 5, sometimes 6 marks. So it is very important to emphasize it, the operation of the transformer. It can be taken from the textbook or previous question papers. All definitions linked to single-phase and three-phase transformers should be emphasized, e.g. different types of powers, apparent power, active power, and reactive power, efficiency, power factor, and many more should be strongly emphasized. The definitions. Cooling methods should also be emphasized. They are very important. Safety devices of the transformer, all calculations. Learners should select the correct formula and substitute with the given data. Units are of most important. No units, no marks. Transformer uses or application, this is also very important. It needs to be emphasized. I think I've touched everything in question 4, the three-phase transformer. Then we can move to the 5th question. Three-phase motors and starters, that is 30 marks. This question is, or actually it was poorly answered last year because we took the last year's report to compile this document. So these are the things that should be emphasized to the learners before they sit for a final examination. Parts of the induction motor should be emphasized. In most cases, in our question papers, they ask the main parts of the induction motor, three-phase induction motor. So the learners need to know them before they sit for exam. The second one, principal operation of squirrel cage motor. So learners should be taught to write it in point form. So in this one, learners should be taught to write it in point form. The principle of squirrel cage, and it's about 7 marks, in most cases 7 or 8 marks. So there are a lot of marks on this type of question. Advantages of the three-phase motor, they are also very important. Applications of the three-phase motor, they are also very important. This one is broad. So that is where most of the learners should get marks. Three-phase motor construction. This is also very important. All definitions linked to the three-phase motor, for example, synchronous speed, slip, rotational speed, learners need to know them before they sit for final exam. Electrical and mechanical inspection. Remember this one, or these two, electrical and mechanical inspection, this was done on simulation 2. So we are expecting all the learners to get full marks if this type of question appears in the final exam, because it was done on our simulation 2, where the learners were inspecting the three-phase motor. So if the learner did not do the practical, it's hardly to answer this question. Circuit components and their functions, e.g. function of the stop, start, the interlock, should be known by the learners. The learner should know the function of the stop button. What is it doing? The start button, also the interlock. These are very important. Let us also emphasize the function of the coil itself. It's very important. Sometimes they won't say the coil, they will say, according to the circuit diagram, they will say is MC1. So the learners must know that when they talk about MC1, they are talking about the coil MC1, the coil MC2, and the coil MC3, etc. Circuit operation, learners should know all the motor starters, e.g. direct online, that was done in grade 11, forward and the reverse, sequence with and without timer, automatic start delta. They must explain thoroughly on how the circuit is operating. I guess if the learners have done the practical task of all these sequences, then it's easy for them to write the operation of the circuit, because it's something they see or they've done before. All calculations, e.g. synchronous speed, rotor speed, percentage slip, active power, reactive power, apparent power, and many more, should be emphasized. Correct formula should be used and the units be included. No units, no marks. Simulation 2 and 3 will assist a lot in this question to answer the questions correctly. So if the learners have done simulation 2 and simulation 3, we are hoping that they will be able to answer question 4 correctly and get full marks. Let's move to the last question. Question 6, PLC. That is consists of 60 marks. 50% of learners do not answer this question at all, or they leave blank spaces, and this question contributes 30% of the exam. (25% of the question in this chapter is a grade 11 work, but the learners struggle to answer most of the questions. In actual fact, they don't write this question, most of the learners. They just leave the blank space. So colleagues, let us try to avoid that. Let us drill this question 6 because of the weighting. Educators should repeat a grade 11 work thoroughly. Subtopics put more emphasis in the concepts such as the definition of the PLC, advantages and disadvantages of hard wiring and soft wiring. This is also very important. These are 3 marks. Definition of the PLC, advantages and disadvantages of the hard wiring or of the soft wiring. These are the 3 marks. Program scan cycle, its name, name and explain the process of each scan cycle. So this is very important. Usually it's about 6 marks. You name, you explain, you name, you explain, you name, you explain. So we need to emphasize the scan cycle. In case it appears, then the learners will be able to answer it. Safety of the PLC devices. We should also emphasize this one, the safety of the PLC. The difference between the analog and the digital. This is also very important. Learners should know the difference between the analog and the digital. A BCD, binary coded decimal, conversion of binary to decimal, this is also very important. Logic gates, learners must be able to identify the logic gate, be able to draw the ladder diagram, logic symbol, and complete a truth table. Please also take note, the definition of sensor is incorrect from the textbook. Please use the one on the memos of the previous question, papers, or any relevant source. This is very important. This one is from national, not from us as Free State educators, but we were told from national that the definition from the textbook, it's incorrect. So they said we need to use the one on the previous exams or any other source. Sensors, only the application of the sensors. So they are also very important. We need to emphasize them to our learners. The learner must be able to differentiate between the on delay and the off delay timer. So this is also very important. Launching concept. Remember, in three-phase motors, this one, we are saying is a whole lean contact, the launching concept. So it's just the same. Is the only difference is it's wording on the concept. And then the markers of flags, memory elements, learners should also know this one. Be able to explain what is a marker or what is a flag. Conversion of hardwire schematic to ladder diagram. This should be strongly emphasized because that is where most of the learners lose marks. The ladder should be fully labeled. So let me emphasize this one. On the ladder diagram, if there are close contacts, the learner can open all of them and the learner will get full marks. Those that I've visited, they know exactly what I'm talking about. When you send the program to the PLC, we open all the contacts. We only close them when you simulate the program. So both diagrams are correct. The one with the closed contacts and the one with the open contacts. But my emphasis will be, or I will say, learners should open or must open all the contacts. In case they close the contacts that are not supposed to be closed. So to be on the safe side, just open everything and ensure that everything is labeled correctly. If it's a stop, it's a stop. If it's a start, it's a start. Whereas you have made it normally open, you will get full marks. Or normally close, if it's a close contact, you will get full marks. But please, learners, make sure that you open all the contacts, all of them, for you to get full marks in case you close the contacts that are not supposed to be closed. Application of the PLC. This is very important. The application, a basic principle of the VSD. This is very important. It always appears in an exam. Methods of speed control. This is also very important. Components, functions on the block diagram of the VSD, the rectifier, the regulator, and the inverter. So let us ensure that learners know what is the function of the rectifier, function of the regulator, and the function of the inverter. Very important. Types of motors used with VSD. This is also very important. Regenerative braking. This is also important and should be emphasized now and then before they sit for exam. The last one, basic application of VSD. So this is also very important. Learners need to know this one before they sit for final exam. Simulation 4 will assist a lot in this question to answer questions correctly. This chapter has to be done thoroughly as it has 30% of the whole question paper. So colleagues, let's ensure that our learners, they master the last question. For them to get a good level and good marks. This is all right. I'm at the end of my presentation. So thank you so much for watching the presentation. I hope it will assist a lot. I thank you.